Welcome to Intralogistics Insiders, brought to you by SYNAOS. Explore the latest trends, challenges, and innovations in intralogistics with industry experts. Welcome to the Intralogistics Insiders podcast. We have today Lennart, co-founder and CPO at SYNAOS. Welcome to the show.
Hi, good to be here. Thanks for having me.
So can you tell us a little bit about how did SYNAOS start?
Yes, so we three co-founders, we used to work in the automotive industry together. We were always interested in digitization of production and logistics, how to transform how things are built and goods are moved on the shop floor by using software and using technology. And we used to work together in an innovation lab in a unit, and we saw a huge potential on how to use mobile robots within factories for intralogistics. And there was a demand within the company we worked for. We did like a market screening and all the stuff which belongs to, and we just saw a gap between what this company with corporate in the automotive industry needed and what was available on the market. And especially we saw like a lack on the technology side, what's available. And we believe that the technology out there is there. You just need to, of course, use it in the correct way to really change it. And that's why we decided to go out, because also we truly believe that innovations need a bigger market than just one customer, just one corporation. That's why we didn't want to do this in-house. We saw the potential and decided to, in 2018, to start SYNAOS.
Many companies in the B2B industrial world, they're very engineering focused. They're very focused on the product, and many times they develop the technology even before they know about the need of the market. Is SYNAOS a market-focused company or a product-focused company?
Well, I would say, of course, when we went out, we did not know the entire market. That's completely true when we started it. But I think it changed over time. So at the beginning, our goal was to build a product and to really solve this problem we saw within one company, but also one industry. We anticipated that that's available there. But at the moment now, over the years, it shifted that we really say, okay, we see different markets, different industries, and we see like the same issues, the same problems arising, and the same challenges across different markets. And so I would say we shifted from a strongly product focused to really becoming more market focused and addressing the needs on different areas, different markets.
As CPO of SYNAOS, what's your role?
So at the beginning as CPO, I was really classically, and this is also somehow related to what you just asked, to product. So I had product and engineering was my role. So really build the product, what to build and how to build it. Now we shifted it. I'm more market facing, so I have marketing, sales, product, and our partner team are my topics. So I'm defining still what to build with the product management and the product management team. But of course, I'm also trying to market it. I'm trying to sell it. I define our go-to market, and this really is something which I have the feeling is good for also product, because we directly know what is out there, what are the customers requesting, what are their problems, and we have a closed loop there. And of course, I'm talking to the technical side, discussing, we want to build this. They tell me how to do it and what are constraints. But I mean, yeah, that's a daily business.
You must be very close to the customers to understand what the challenges, the problems, what they need in this world. What do you see as the biggest challenges right now in intralogistics?
So from my perspective, it's often a transformation challenge, because, I mean, we have cost pressure, we have labor shortage for forklift drivers and stuff like this. I mean, we especially have cost pressure here in Northern America, but also in Europe, but also in Asia, it's coming up because salaries are increasing and also labor shortages over there. So those are the classical challenges we have, and we need to overcome them. And you can overcome them with technology, introducing software, which is making your factories, your warehouses more efficient. I think being able to use it, to utilize the power of software, of new technology, really is also something where customers need to learn that they might change how they did things before, that maybe like your manual processes cannot be completely overtaken into the new area into the new era where you go into a digital manufacturing world. So this is definitely something the organization change. Big customers need to face when they go this way is one big challenge.
So you mentioned mobile robots, you mentioned manual operations. What has been the progress of intralogistics in the last 20 years?
Yeah, that's so back in the days, from my perspective, I mean, everything was moved manually. People were involved, people pushed carts around, people had some equipment where they put some stuff on and they pulled it, and they were just doing it as good as they can by their knowledge. So they just run around, they see stuff, they see like there's an empty pallet, I need to move it, and they directly know because they're trained on it. Okay, when I remove an empty one, I also need to refill it with this kind of parts with a full one. So it was really like on site, just looking and knowing what to do. Then of course, like forklifts or you can also do it with forklifts, and you're faster and you can transport more heavy stuff. But the basic principle, how you are designing it, is the same. So they're driving around and doing their best to refill everything what they can. Then systems came in, IT systems came in, based on demand, based on orders you get from upper level system. You generate like prioritized lists. So you have a pool of drivers or pool of people who can do intralogistic work. They have a prioritized list, and everybody just picks always the highest order. This is of course better than just having people driving around and looking what to do, but still it's not really well organized and well optimized, because it might be that someone who is in the upper right corner of your factory takes the next urgent order, but this requires him to drive through the whole factory. So there's really no optimization and no decision who is going to take the order based on where they are and what they can do in this way. And this is now with Industry 4.0, smart factory, IoT, where everything is connected and you have information on the shop floor available, which you can use and which you can feed into your systems to make smart, better decisions. This is now what's changing, so that you really can optimize your how intralogistics is running. And this is just the planning of it. And then, of course, technology also on the hardware level is coming in. Not everything is driven manually, so people are replaced by autonomous mobile robots. So they take over jobs, they take over tasks to do. They are more reliant, they are more repetitive in the work. So this is something which is definitely coming in. And I mean, if you look in the future, I strongly believe that the mode will often be hybrid. So I don't believe that the dark factory is going to be the thing where it's going, because humans have benefits doing some tasks which are tricky in handling and depending on the equipment you need to use. But mobile robots are really good at doing standardized work and doing repetitively. Additionally, it might come further changes. I mean, humanoid robots are some hot topic which is coming up. I believe it will take some time till they come. Others say they will be there in a year or something. Let's see. But those are definitely interesting things. But I still believe that human and being human drivers will always be a part. But of course, they will be used for really the tricky and the most critical parts of it, and everything else which can be automated, standardized, and automated will be automated.
Before talking about humanoid robots, which is in fact a very hot topic, mobile robots still, the penetration is not that high.
Yeah.
Few companies are still using them. So what do you think is the biggest stopper right now in the integration of mobile robots?
So from my perspective, it really depends on how capable the vendors are on the embedded software side. So we really see a huge difference in depending what kind of mobile robot we are using underneath our system, what they can do and how reliant they can do it. So there are really companies out there, it's more or less plug and play, and this is where of course everybody needs to go, that you really get a standardized that you get a robot which has a standardized communication, where are standards out there and you can really plug and play use it. But there are others which are far away from this, so they have like really their own way of thinking, their own way of communication, and you need to have an integration, and this all slows down how many robots you can deploy into your factory. Then furthermore, on the system level, on the IT landscape level, software as a service is coming in. So that a company is not hosting software on site, having their own data center and need to take care of everything, but there are providers out there who can offer this service as software as a service, and they are trained for this, they have experts for this, and then if you decide to go in this world, in this solution, you can scale much faster, because they can just give you a new instance, a new tenant for your new production facility, and then you are ready to go, and you don't need to talk to your local IT to put everything up, to host it in the data center and stuff like this. So this is also a big change and something which is really accelerating.
There is a flourishing industry of more specialized mobile robots, both AMRs and AGVs, mainly because there is a need for a specialization, for being able to perform different tasks in different environments, different scenarios. It's not counterintuitive that standardization is going to help this flexibility in implementing mobile robots.
So I mean, I think standardization doesn't mean that you cannot be like individual on the hardware level and what your robot can do. That's not what I wanted to say, but I think from the operational perspective, so how is like the business logic, who has to do what at what point in time, who has to transport the first order, who has to transport the second order, and who is allowed to drive first over an intersection, who has to wait and stuff like this. This kind of logic from my perspective should be standardized, that you really make them interoperable. But of course, the individual strengths of each vendor, like the one is better in like avoiding obstacles, the other one is better in lifting stuff up or picking it in different ways or whatever, they need to be of course conserved, and they need to be used, because this is like also the USP of the mobile robot vendors and what they are good at. And the customer also selects different vendors because they have different strengths, and this needs to be conserved. But this, from my perspective, has nothing to do with the upper level system and the standardization between an upper level system and the system which is running on the robot. This has mainly to do with how capable the software on the robot in combination with the robot hardware is.
Considering the peculiarities of different robots, they can have different speeds, different navigation, perception, mapping, different physical attributes, heights, how big a corridor they can navigate. It looks like a daunting task to define priorities and plan based on that. How is it done?
It is a complex task, and it's definitely a challenging task. I think, but I mean, there for traffic management, like to deciding who's going to drive, and there are algorithms out there. There are possibilities to do it. We do it based on envelopes, so we have like a completely envelope based, depending on how big the robot is, what kind of load is on there. Sometimes the load is overreaching, so it's even made bigger. And then we have standardized ways on how to decide based on rules, how based on deadlock prevention algorithm, that nothing gets stuck, because I mean you also have one-way roads, you have and stuff like this, and this is everything is considered constantly in our calculations, and then the one we believe is the best one to go now gets like the confirmation to go across, and the other ones have to wait. So it's really complex, and this is like the core also of our one of the core parts of our products, making the traffic management as seamless as possible. With having like heavy deadlock prevention algorithms and stuff like this, but this is something which can be solved in a good way today.
Does this complexity get transferred also to the end user in terms of commissioning, or is it solved by SYNAOS?
In our system, it's solved by us. So what we do is we create for each mobile robot vendor, we create like a virtual map, a navigation graph where he is allowed to drive, okay? And this is depending on the attributes of the robot. Some robots need like really dense navigation graphs with like nodes every 1 meter. Others need bigger ones. So this can be done individually to what the robot needs. This is all packed into one map, and it's like a layered map. And our traffic management works like vertically across all the different layers. And then once you have done the configuration, like this robot is allowed to drive there, and I put the map layer in there. Then the next one is allowed to do there. I put the map layer in. Then the traffic management takes it by themselves. We make it visible to the expert user of our system if he wants to. So there's a mode where you can trigger it, where you can see the different reservations of the area reservations of the traffic management based on which vehicle. So because sometimes it is good to see who is going to go first and how the system is deciding this. So some expert users want to use it, but it's nothing which is a pre-requirement that the users need to somehow twerk the traffic management.
Okay. Flexibility is a hot topic as well. Also the scenario in which mobile robots operate, not all mobile robots, but also manual operators and forklifts change over time. How do you respond to this change in the map, in the situations?
Yeah.
How is this solved?
Yes. So let me start typically how like mobile robots started to come into factories. And so typically companies looked at like single use cases. Okay, so they did like, okay, there's a one source sync relationship. I have to transport something from there to there. Okay, I've standardized like objects I can move, and so I introduce like 2 or 3 robots. Probably I only need one, but I introduce 2 to have like a spare one on this course, and it's just a round trip. Okay, so it's based on some sensor data. I know when to drive, and it's just a round trip. And this, initially it was done with magnetic tape and stuff like this. Now it can be done more flexible. You don't need anything on the ground. It's virtual SLAM, so they know where to go, but still it's like a round trip. And we see this really often in the industry. It's still done today that companies only do this isolated processes. And then they do it over time more. And at one point in time, they see, okay, I have overlapping areas and it's really getting difficult. And what we immediately do and what our system is capable, of course, we can have isolated courses all around. That's not a problem. You can easily do it. But what we change is, and which gives like a way higher flexibility, is that we, if it's possible from the robots that they can drive everywhere, we allow them to drive everywhere. So we don't have isolated courses. We don't decide on fixed associations that they only are on this mission and allowed to do these orders. We decide based on capabilities of the robot and requirements from the orders, like what kind of good needs to be transported, who is the best out of the whole fleet to take an order. And by this gives a huge flexibility. So this robot doesn't need to drive here and there's no order, it just waits. And if it's needed somewhere else, it will get sent somewhere else fast. So this is one part of flexibility, how we adapt to, for example, different order pools, different changes in what is the demand. On the shop floor level, there's also high dynamic, as you said. So maps get so things get moved around. The source sync relationships get moved. Handling stations are changed like this. And there are different ways to do it. Of course, we have an editor in our product where you can manipulate the behavior on the shop floor based on some virtual objects or behaviors you can introduce in our product. But you always need to consider that changing a map is something which you can do in our system, but which also need to be like compatible to the mobile robot. And there are different needs of the mobile robot depending on the mobile robot vendor you are using. And some of them are really flexible. They just can use coordinates. So we tell them XY coordinate there, go there, and then they're good to go because they have mapped the entire floor and they have like dynamic mapping algorithms on the mobile robot to update their own map, and that's totally fine. Others are, and those are more the older ones, they are really not that flexible and they need to have like a fixed map on the robot. And then and with those ones, we are not that flexible just to change something in our system because it needs to be down to them. But we have, of course, ways introduced that we can upload a map which has the robot created into our system, transfer it. So it's working both ways, let's say it this way. But the way easier and the modern way where we are going now is, from my experience, that we really have not the high reliant the dependency on the map based on the robot, so that it's more transferred to the upper system, and then you can change a lot of stuff. In our product, to become more specifically, we have introduced a shop floor model. We call it shop floor model. It's like the virtual representation of the shop floor. Everything is in there, like your handling stations, your driving ways, and everything which is, it's like the digital twin of your factory. Let's say it this way, which of the parts which are relevant for intralogistics operations. So the shop floor model. In our system, you have an shop floor model active. This is one where everything is operated on, okay? So the current shop floor model. What you can do is you can transfer the shop floor model to a simulated instance. So the completely same product is running, only AGVs or mobile robots are simulated, orders are simulated, or you even get the same orders out of the productive system from the customer. And then you can change this shop floor model. You can have an editor. You can say, okay, I optimize some parts. I change the layout. I do whatever I want. You can test it in the simulated area. Okay, you can really optimize it there. And then once you are done, you say, okay, this is now optimized. This is fine. I'm good with it. You transfer it back to the productive system. And then you have 2 shop floor models in there, the one active one, the one which is not active, and you can initiate a process that the active one gets replaced by the other one. And of course, it's not like switching now because orders are executed on the active one, and if you remove the handling station but an order is going there, you cannot tell the robot that he's not allowed to go there anymore. So there's like a process going on, but it's like a controlled process that it's always in a stage where it's working, and then the model gets automated switched.
You mentioned at the beginning that one of the big challenges is this transformation, no? Digital transformation of the factories, of the warehouses. Who do you think are the key players here in this transformation? And what are the key things that they need to have in mind, or they need to consider in order to be successful in this transformation?
Yeah. So the head of production, head of logistics of a plant, of a facility, I think they are really critical for successful transformation towards an automated and a digitalized plant or intralogistics. So because I mean they need to have a vision. They need to have a vision on, of course, automation is an investment. It's an investment now, but you need to have your payback. You will have it later, and this is something they really need to have a vision. Not saying, okay, I only look at this isolated cases because I have a bigger picture in mind. I really see that I want to have, for example, like 80% automated transport, and the rest of them is 20%. So I need a solution how those two worlds are working together, and this is critical. Of course, on the other side, another really important person is always the IT, either like a central IT in big corporates or the IT who's really taking care of the factory, because they need to be willing also to change. Today, automation is PLC based. So people are bringing in PLCs from any company, and PLCs are, I'm not against PLCs. So if you have any like critical and safety critical communication, it needs to be done by PLCs. So don't get me wrong. You cannot do safety critical stuff from a cloud system. Okay. But what's really important is that you find the right level for which you use like the PLC-based automation and for which you use like a real software-based automation. And this is something where the IT department needs to understand, because in the past, companies do everything on PLCs, okay? They do like the whole automation, they do on PLCs based on input, and then they have rule-based decisions. This is working, but this is not really changeable easily, and this is also not scalable. And this is really what needs to change. And the production, logistics, and the IT guys need to be aware of this and need to be willing to do this change.
You mentioned IT, head of production. When does it make sense to go for this transformation instead of company size, in terms of industry you're working on?
Mm-hmm. So generally in intralogistics, and there are different parts on what makes sense. So first of all, optimizing your intralogistics is for my understanding, you must do it today, because you have cost pressure, you have labor shortage. And when we look at intralogistics today on the market, how are transports mainly done worldwide? It's manual transport, okay? And from my perspective, it's kind of, I always question this, and it's kind of ridiculous. Why is the acceptance for inefficiency in manual transport so high today? Because most systems or most facilities are operated, as I said at the beginning, on site. So people are just driving around, running around, looking what to do, and it's not optimized. The next step, as I said, is having prioritized lists, and those are the two modes you will find today, okay? But what when you analyze how the operation is done today, you will find that like 40 to 60% occupation rate of the really having productive occupation of the vehicles is only done. So there's a high level of inefficiency, but it's somehow accepted. Okay. So this is the first step. So if you look at intralogistics mainly done manually, you need to change the way how you use the resources. So you really need to introduce a new planning approach, which is directly transferring orders to each system, and based on where they are, what they are doing, they are optimizing it. And by this, I think every intralogistic which is using manual transport needs to do it now, because there's a potential. You have issues by getting drivers, and this will maybe decrease the number of drivers you need. So then the other part we see, of course, is introducing mobile robots. Introducing mobile robots, as I said, is an investment at the beginning. You need to invest into education of your people. You need to invest into the robots. You need to invest into the right automation, into the right software system behind it. From my understanding, if you look at cost and ROI, as soon as if you have 3 shifts, there's no question you're burning money today if you don't introduce mobile robots. If you have 2 shifts, it kind of depends on how, in which country you are. But if you have two shifts, you are in Europe, you are in Northern America, or in high cost countries, there's also, you're more or less burning money today by not using mobile robots, because you will have a ROI of 2 years or less, and this is gonna work if you do it with the right equipment and with the right system behind it.
This podcast is brought to you by SYNAOS, the all-in-one intralogistics platform, orchestrating trail flows with mobile robots, forklifts, and people to overcome cost pressures and skilled worker shortages. Visit synaos.com to learn more. As you mentioned before, most companies start by automating one process. Mm-hmm. They then jump into the second process. Does it make sense to wait until you find the problem of the coordination of these heterogeneous fleets, or should they be looking at it before they have the problem?
So what we see a lot of companies doing it the way, or the way you said first. So going for one case, going for another case, adding a third case, going for the next plant, adding some cases. Then there's an overseas plant is coming, telling, hey, I also have a case, and I used a local vendor for doing it. What we really see is this is totally a valid way how to do it, okay? So it's totally fine. You can just start simple and go this way, but you need to be sure, and you need to have in mind that you will have changing costs later on. And you can avoid those changing costs if you start from the beginning by thinking it bigger, by making a clear cut between the upper level software system and the hardware and mobile robots you're buying. So that's possible if you do it from the beginning, but it's also possible to introduce it later when you have the pain, when you've experienced the pain and you have collected some experience. But of course you need to be aware that there's a cost of change, and you have bought some IT systems from the vendors you might not need anymore. So the hurdle to really get this to this point and to get the decision is increasing from my perspective. So that's why I, of course, recommend to start thinking it from the beginning and find the right point in time. Maybe it's directly the beginning, maybe it's after like one project and you only do like a pilot phase with one other system and then you switch. But the later you will come to this decision, the more it will hurt you, because the pain is increasing, but the cost you invested or the money you invested already is also increasing. So it's both ways are working, but both have advantages, disadvantages, and it's basically a decision from the company.
When integrating different mobile robots, it looks like very reasonable to have to coordinate them, to synchronize them. You give them orders, they do what you want. But when you're talking about manual operations, how is this done? Because these are people, we make mistakes, we're imperfect. So how is this coordinated, and how do you expect them to do things, or how does it work?
Yes, so we provide them with an interface, with an app on a device which they have with them, a mobile device, whatever. And in this app, of course, we tell them what is the next order they have to do. Okay, we tell them, okay, you need to go pick up this kind of pallet or this kind of transportation good at this location. Please go there. Then the driver is going there. He is scanning, or sometimes he's just confirming on our app. So it depends on how the customer is setting up processes. And then he gets the destination, where to drive to next, where to drop this off. And this is pretty simple. Basically, we are doing this with the mobile robot the same way, okay? It's the same system, they're completely integrated, just the communication to the human is of course different than to a mobile robot. The human can understand, doesn't need all the details like a mobile robot, but and is more, you can give him the freedom also to how to get there more, and that's how we are doing it. And what we also offer in our applications, of course, more interaction possibilities, so that he tells us, okay, now I'm doing something else even though you told me, or okay, there's a problem because the pallet is not there, and what he's reporting stuff like this. So there are more interaction possibilities for the human, of course, within the application, but in total it's the same. What's changing is traffic management, because we are, it might be in some next releases, some time that we introduce like a Google Maps view, that we really tell them, okay, you go now this way, turn left, then 100 meters, turn right. And it might even be that we give them commands to say, okay, please wait, so stop at this intersection because something else is going through. At the moment, we don't have this, and it's also So I think it's not available on the market, and we are still in the discovery phase if this is really acceptable, to be honest. So this is just an idea. But how traffic management is done today, of course, we are not giving them like each part of the road, we are confirming them to go. We only have like on critical intersection there are like traffic lights or something, and based on this, and our system can also set them. If we have confirmed a mobile robot go through, we of course are setting the traffic lights to red, that the manual operators are waiting and stuff like this. Another way, and that's also possible if you don't want to integrate traffic lights, other equipment into your facility, we can block fixed areas around manual vehicles, okay? So they have like fixed reservations with like a certain horizon up front, and then they are driving, and as soon as they are going somewhere, it's reserved, and then we cannot reserve it with other automated robots, and that's also a way how it's working. So it depends on, you want to give like who's more important for you, or who do you want to give like the first step. If you say, okay, the manuals just need to do what they want, and then you can just make a zone blockage around like a vehicle on a fixed base. But if you want to that the system decides who has the more urgent order and who's what's better for the entire traffic flow, then you should integrate traffic lights, and maybe later on we will have even more detailed traffic management also of manual vehicles by having like this Google Maps view.
There may be some friction between workers and mobile robots, but from what you explained, there may be even more friction if you want to control people with an app. Is this a challenge that you have seen, and how do you overcome it?
Yes, definitely. I mean, you need to have acceptance. You need to have acceptance by people for any product, for any technology you bring into a facility, and they are used to do it differently, and you are changing it. And of course, we are trying to design our product, and of course especially the interaction we are with the app for our forklift drivers, we are designing it that they don't have the feeling, okay, they are commanded by us and forced by us to go this way and do this, okay? So that's why we try to make it as flexible as possible, and then it's also more on the like operations, like on the production guys, on the logistics managers, to really tell them, guys, okay, please follow this, and please follow this as good as possible. Or you give them more freedom, say, okay, it's like a recommendation for you and you should do it, but if you think you really need to do something else, you need to use the app to tell it that you do something else, but you're free to do so. So we are trying to increase the acceptance by not making it like strict and forcing them to do this. This is one part. And of course, there are also other ways, making it fun to work with the app, making it more comfortable, making the jobs easier than it was before, which also increases the awareness and the acceptance of this technology, that it's helping and that it's good. And we also did like a hackathon where we, for example, tested out gamification on this part, so that you select some coins, or that you get like an award for each order, and then you have like for your shift you have like a ranking. Okay, today Peter did the best job, and the next day somebody else did. So just to bring in some fun factors and some motivation factors, this is something of course we are always also thinking about.
You have worked with big companies that have been for a long time integrating mobile robots. You probably have experience also integrating those into your software, and how the integration went with your own customers. Without mentioning brands, what do you think are the key things that companies that want to do this digital transformation should look into mobile robots when choosing them? What are the key things that make this integration easier?
So it's definitely how they use standards to the communication to the upper level system. We are using VDA 5050. It's pretty common in Europe. It's becoming more popular also in the US. Worldwide, I think there are at the moment 3 to 4 standards evolving. From our perspective, VDA 5050 is for this kind of communication the most evolved one. And that's why this is one recommendation I would have for every customer today. Really look at how capable the software vendor, the hardware vendor is on communicating via VDA 5050. I think the map topic is a big topic you need to check. So how flexible or how inflexible is the mobile robot vendor on this onboard software by using maps. And the navigation technology also needs to be checked. For some use cases, it might even be okay to have like inflexible navigation based on QR codes or whatever. and it always depends on what use case you are covering. But if you see that you have a changing environment, that you really want to be able to have flexible use of mobile robots, then of course you need to make sure to have the right navigation technology like virtual SLAM in place to really also have the capability on the robots to do this. Of course, there are a lot of technical and hardware related facts. I'm not the best hardware guy for mobile robots, to be honest, so I'm not giving recommendations there, but this also needs to be checked that the payload is right, the driving behavior is right, that the speed is like how you envision it, that the orders are on time and stuff like this. Of course, this all needs to be checked, so it's definitely a complex selection process, but I think what was done wrong in the past often was that only the hardware parts had been checked, and then the software has to work, and also the backend system, the fleet management has to work. And I think this really is my recommendation, to not do it this way, to really also have a focus on the onboard software and the fleet management, because only if the overall system is working well together, it can be a successful project.
Based also on your experience, just out of curiosity, what are the most interesting applications of mobile robots that you have seen integrated?
Well, I think automotive industry is like on large scale is like a really interesting cases. So having fully automated assemblies, the delivery of goods to assembly lines in automotive is definitely something which I think is like on the forefront of how to use mobile robots. You have high intensive intralogistics is highly business critical. So as soon as like orders are coming late, your production belt will stop, and like the loss of cars like you're producing is there. So this is really, of course, a challenging environment, but also a really interesting one. And there are huge numbers, more than 100, 150 robots driving around. They are all coordinated, different types, because you have different goods to transport. So different types used there. So this is really a high complex and high diverse intralogistics scenario. So this is really interesting. What we see also is, or what I also think is really interesting, is how industries where other requirements, for example, on the cleanliness of the facility, food and beverage, battery cell factories and stuff like this, how they are introducing more and more of those parts. And for example, in the food and beverage, in the bakery world, it's really interesting because you have other failure modes. If your intralogistic is not working, you're handling like natural resources like a dough or something, and if the intralogistics is not working, either your dough will be everywhere because it's just going crazy, growing crazy because it's still under heat and you're not transporting it. So this is of course challenges and a really interesting scenario. Or your oven will start to burn because the natural ingredients are too hot and will start burn and stuff like this. So that's of course interesting use cases, I would say.
Where are the limits of what is a mobile robot and what it isn't? So just put the example of semiconductor industry. You have these overhead rails, and they are mobile and they are robots. Do you consider them mobile robots?
Well, I think I would rather put them in like stationary and or conveyor systems, to be honest. So I mean, they have just fixed route and predefined routes where to go. So mobile robots is something for me which is without any rails to go on paths. And of course, then there's also decision when it's like a autonomous or automated one. But I would just put mobile robots in one case. So as soon as they can go different ways and are not on fixed rails, I would say it's a mobile robot from my understanding. It can be simple ones, can be more complex ones, but everything else which is like on rails, and that's again, it's like PLC based automation, which is required on this one, I would put more on the normal robotics and automation equipment world.
Going back to one topic that we stopped before, we have new types of mobile robots coming in, for example, humanoid robots. Are there right now in the industry, or is this something of the future?
Well, I think Tesla is making news that they are using like 2 humanoid robots within their Fremont facility or Texas. I'm not sure. So they are used. there are also like German companies going in this field and really making promotion out of it, that like within 12 months or within the next year, they will be available.
BMW, I believe I saw some news that they were using something.
Yeah. Yeah, and I have to admit I'm a little bit skeptical. I have what I think is we talked about manual transports, okay, easiest mode to do, but maybe not the most efficient one because it's not humans working, not system bound, and so then we are going to mobile robots, like where the coordination on how a transport is done, of course, with 4 wheels or something, is way more easier than having legged robots walking and being able then also having 2 arms and do stuff. But still, we see like challenges in this field. Then companies start to put in cobots, so based on mobile robots, mobile platforms, which are wheeled, putting in some like mobile manipulators with it. I mean, those cases are coming and they are also working, and it's also possible to do this, but still today, because of gripping and stuff like this, is limited. And now going even the next step to say, okay, really putting those legged robots, the humanoids with arms in there, I really believe that there will be use cases which can probably be done easily, but they will be limited at the beginning, and it really will take time until they are ready for more general cases. That's my opinion and my prediction.
Where does the SYNAOS name come from?
SYNAOS, it's synchronizing chaos. So we thought about what is our product actually doing in production and logistics, and then we were with like orchestrating stuff, but then we say, okay, there's chaos today and we are synchronizing it. Our goal is to synchronize it and to make it more efficient, and then synchronizing chaos, and out of this came SYNAOS.
This chaos is not only in logistics. This chaos doesn't start and finish inside a factory or a warehouse. It's also outside of it. It's the delivery trucks. It's people driving on the streets. Right now, SYNAOS is focused on intralogistics and factories, warehouses. Where does your solution connect on the upper level and the lower level? I mean, on the lower level, I understand you interface with mobile robots. Where is it interfacing on the upper level?
Yeah. So on the upper level, it's usually enterprise resource planning system, ERP system, or WMS, warehouse management systems, where we get orders from, and of course where we confirm and interact with. So that's the typical integration, SAP, Oracle, who you ever name it, what's around there. Many customers have own systems built, so but that's the typical level. Some customers have below ERP systems or MES system, manufacturing execution systems, also something which might be, and they have like already a layer which is called TLS or TCS, transport control system. Okay, that's, I think it's automotive has it. It's kind of special. So, but this is also something. But in the end, we need to have intralogistic orders, transport orders. That's what we need to know from the upper level system. We need to have some more information. Then it's good if we have the right, if we know the latest delivery times, if we know what's the good we have to transport, what it looks like, and like what are the dimensions, weight, and stuff like this. This is something we also need, but it's not really heavy integration. We just need orders and some more information for it.
We are optimizing so much the factory and the warehouse. Are there solutions right now outside of that, for example? Because there are trucks that are going to go somewhere else. Orders, for example, that have to manage the production, both the trucks. Are there solutions right now? Or is this something may in the future come?
You mean along the supply chain?
Yeah.
So yes, there are some. I think the focus on the supply chain is at the moment more on tracking. So there are companies out there who allow tracking solutions, and then you have like certain milestones, and based on this, and geofencing based on this. For example, a truck checks into a plant based on a geofence when it reaches a different certain distance to a plant and stuff like this. I think having the need for really fleet management like we are doing it within the facility will become stronger when autonomous driving really hits more. And I mean, a lot of companies are struggling in autonomous driving on the streets at the moment. I think that maybe on the on the area of a plant when you checked in, but you're not within the facility when you are driving between different halls. There is already cases coming up. So this might, from my perspective, be the next step. So not only within the four walls of a factory, but then on the whole area around it, on the yard around it. Those might be the next cases, and then okay, it might come at one point in time that also autonomous trucks are there, and then fleet management becomes a different requirement also on the streets.
We have talked about mobile robots. We have talked about humanoid robots. Next big topic is AI. So
has to be.
Where do you see it, the biggest areas of application of AI into intralogistics?
Yes, from my perspective, I think AI is also already today applied in many intralogistics or production facilities. So it's not the large language models which everybody's talking about. It's not always like the machine learning which also people have in mind. But there's also an area which is based on meta heuristics, so that you, for example, so if you have a scheduling issue or if you have a scheduling problem in your factory, you have like a huge order pool and you have resources on the shop floor which can do it. As soon as you hit a certain size, and the size is not big, okay, this challenge cannot be solved mathematically correct in the available time. Okay, so you need to find optimization methods and ways and algorithms how to solve it to become close to the optimal solution. So there algorithms and heuristics are in place, which are combining certain methods, simulated annealing, just to name some, which are also in the AI field, if you look like this, but which are not like going through the press because it's not that fancy to have like an assistant or whatever. But they are used, and we are using them also in the order optimization, how to allocate orders to different resources. So there are already today applications, and this application brings enormous efficiency by how to utilize your transport units on the shop floor. I definitely see also in large language models and this ChatGPT and whatever is around there also a huge potential. Of course, just that you feed it with data, that you give it knowledge about the product you're using, knowledge about your intralogistics scenario, and then you can just ask or as you chat with it and get simple questions and get good answers on it. This is definitely something I see also potential. We already tried this. There's the thing is, of course, there are also coming sometimes wrong answers. And if you are in a business critical environment and then, for example, you use it for your support and it gives one wrong answer, and then in the facility something really happens which should not happen, you really need to weigh out the risk at the moment to use it to really be based on this and the benefit. So it's still I think you need to get the certainty that it's right. What you are getting back needs to increase still a little bit.
Engineers, when designing products, we try to make them perfect and make sure that we know what's going on, what's the input, what's the output. This question that you just raised happens also in autonomous driving, for example. Mm-hmm. You know, you have to make sure that the autonomous driving is working properly before. But if you look at what humans are doing, they make mistakes every day. Yeah. There's people dying every day on the roads. Yeah. But when we want to launch a FSD, you want to make it perfect because at the end, it's the company that is providing this that will be liable. Yeah. Do the systems need to be perfect in order to be able to implement them? Or do they have to be better than we have now?
From my perspective, they need to be better to have a case and also to make a business case behind it. Of course, the requirement often is, okay, it needs to be perfect. It's automated. We can talk to like rocket. We can send rockets to the moon. Why is my mobile robot not working here? Okay, so I hear this, and of course, you can always argue like this. But I think it really needs to introduce improvements. Okay, and from my perspective, a product. Doesn't need to be perfect and will not be perfect, to make it clear, but it needs to be supported, and it needs to be have capabilities and allow human users and experts to, if it's not perfect, in the situation where it's not perfect, to interact with it and give it like a hint or give it like some input on that it's solving and overcoming this imperfect behavior. So this is really something which I believe is important to have in mind when you're creating a product for like production and logistics, which is critical, where everybody is expecting something smoothly working, perfectly working. No product will be perfectly working, but you need to make it bring it back to a like working state as soon as possible and give interaction possibilities.
What you're mentioning is very close to customer centricity. How do you implement customer centricity at SYNAOS? You are responsible for products, so...
Yeah. I mean, we are talking a lot. We are collecting requirements. We really try to understand what's the problem, the core problem behind it. So we often, and I'm not blaming them, but customers often have a solution in mind. So they have good people and they sat together and really elaborated stuff, and then they say, okay, I need this. This is exactly what I need. And what we are trying to do, and this is also the product mindset in our company, we are listening and we want to solve the customer's problem. And if he has a good solution, we are not saying no, but we really need also to understand the core problem behind it. So what is really the thing we need to change, and what the customer has the pain point. And then we, of course, collect those requirements, those problems, and really try to map them to what our product can do today and how we could solve it in the best way with our product. And that's a constant process. We are talking to all our customers. We are getting constant feedback from our leads and from POCs and whatever, where like still some room for improvement is. And that's basically an ongoing process our product management is doing to really be aware on where the trends are going, where new pain points are arising, and also going with the technology, because also there it's always evolving. If you look 2 years behind, the map topic was not as big as today, for example, okay? Because there was more, everybody was on, okay, just make it run, and I want to have it run once, and then I will not touch it. And now everybody's saying, okay, I see I need to change like every few weeks, I need to change it, and it's like a real pain. And now the map topic is coming up. So you always need to see where it's evolving. The whole market is evolving. New pain points and new like hot topics for customers are coming up, and you just need to be aware of it and then find a solution how to solve it.
How do you think more synchronized intralogistics in the coming years will make a better world?
Well, I mean, we have seen, I think, during the Corona pandemic, we have seen like how volatile supply chains are, and in each supply chain, I mean, every country is reliant on supply chains. Okay, in Europe we are exporting, importing everywhere, and there's like a real demand on getting goods from outside your country, outside your region. And what people often forget is when you look at the supply chain that there are many hubs where like stuff is shuffled around from A to B and put on another container or something like this. And this is all intralogistics, okay? It's not only factories producing some goods, it's also warehouses transferring stuff from A to B and then cross-docking and sending it further. And this is like a huge part of the economy also, and making this more efficient and also more reliant, okay, saying, okay, we really can have stable operations because we have a good level of automation in there on a recent and on a good cost basis. I think this is really something which can benefit. And of course it's also hard to find people being able and being willing to work in those factories. I mean, more people are going to university and they don't desire to drive a forklift or to pack some stuff from A to B. And there, I think having the opportunity to combine human workforce with robot workforce is really something which helps to have a stable, reliant supply chain.
Is it possible to improve operational efficiency without investing in mobile robots?
Yes, it is. I mean, if you have forklifts running, they can be optimized, and this is also something we are offering. We are trying to bring our customers on the journey towards digital manufacturing from different angles, and of course as early as possible. And many customers today have only manual operations. They're driven by forklifts and operated by forklifts. What they often do is they take our real-time localization. It's a sensor kit you can retrofit to a manual vehicle, and then you get the position out of it. And then they just use it for some weeks, equip their 5 forklifts with it, and then they get all the data out of it, all the position data. We can also say if there was something on the fork or not, if they want to. So we have an extension for this, and based on this, we can tell them how good the intralogistics is running. So you can analyze it. Where had they been? How much time they had been in work? How much not? And based on this, then we can introduce our forklift guidance systems, and as we talked about it, provide the drivers with the app and try to control or try to give them better options, orders to go and what to do. And based on this, we already go into a more synchronized and more orchestrated intralogistics. And the interesting part is, and this is also something which we see is really interesting for a lot of customers which are not ready today to say, okay, I just throw in mobile robots, is they can start here. Then they can start using single cases for mobile robots, and they don't need to have a change in the IT landscape again, because they then just plug it into our system, extend the configuration and the commissioning a little bit, and then they're ready to go, and it works perfectly together. So this is the journey we see often, that we get them where they are today, manual world, and then we transferring and go with them into the automated mobile robot world.
Thank you very much for sharing your experience with us today. And hope to see you back soon on the show.
Yeah, thanks for the discussion. It was a pleasure talking to you.
Thank you.
Thanks.
Thanks for listening to Intralogistics Insiders. Stay tuned for more insights and subscribe on Apple Podcasts, Spotify, or your favorite platform.